Hi class, this is algebraic expressions. So polynomial in x is a sum of the form, and they give us this expression here. Notice there's coefficients are a sub n's, and the variable is in x, and the exponent's reduced by 1, left to right. And this first one over here on the right side is a constant. All right, so the degree is n, which means it's the highest exponent. So let me show you what some examples of polynomials would be. 5x to the third minus 2x squared minus 1/2 x plus 2. That's an example of a polynomial. Another one would be x minus 1. Another one would be 1/12 x to the fourth minus 3x plus 1/2. These are all examples of polynomials. Examples of expressions that are not polynomials would be like 3x to the negative 2 plus x minus 1, because the exponents cannot be negative. They have to be non-negative. All right. Another one would be 5x to the 1/2 power minus 3. Once again, the exponents must be integers, non-negative, and 1/2 is not an integer. So these are two examples of expressions that are not polynomials. For this other first example here, they want us to multiply. There's a couple ways you can multiply. I think a lot of you guys may know the FOIL method, so I'll start off with that. So that would be first, which is 10x squared, outer, which is negative 35xy, inner, plus 6xy, minus 21y squared. And these are like terms that we can combine. That's going to be 10x squared minus 29xy minus 21y squared. Okay. Now we're going to factor, which is basically the reverse of multiplication. So whenever you have four terms like this, 1, 2, 3, 4, notice that you can group these first two and take out the GCF, and then take out the GCF of these last two terms, and then you're going to be doing what's called factoring by grouping. Factor by grouping, which only works when you have four terms. So let's do that. We'll put our parentheses around the first two terms. We'll take out our GCF here and here, which is 3x squared, which now leaves us with x plus 1. If you factor out a 3x squared here, you're left with an x. And if you factor out a 3x squared from here, you're left with a 1. And you can verify that by distributing, you should get that expression back. Let's do the same thing here. The GCF here would be negative 27. So negative 27, that would leave us with x plus 1. And if you're doing this correctly, that means that these two factors will always be the same, which they are. So now we can factor this out of this. This now becomes the new GCF, which can be factored out. So if we factor that out, what we're really doing is we're dividing it out. I'm not showing all my divisions, but if you can show your divisions here if you want to. And that now leaves us with 3x squared minus 27 after we've factored out the x plus 1. And notice that there's a common denominator or a common factor here, 3. So we can take out the 3 now and move it out to the front. And this becomes 9. So now we have 3x plus 1, x squared minus 9. And this is the difference of two squares, which can factor into 3x plus 1, x plus 3, x minus 3. That is the complete factorization of that problem. So be careful, just because you've done the factoring by grouping doesn't mean that there isn't a GCF like there was here. And there can also be a difference of two squares, which there was here. All right, when you have a trinomial and they're asking us to factor, look for a GCF first. There are none. So now you can do a diamond, and that would look like this. And I always put a times c in the top and b on the bottom. So this is your a, is 7. your B is 10, and your C is negative 8. So the diamond says that it's A times C on the top, which would be negative 56. And on the bottom, you want the B coefficient, which is 10. And now our job is to look for two numbers whose product is negative 56 and whose sum is 12. And for that, we just have to kind of guess and check. I think 14 and 4 might work. Yeah, 14 and 4 work. 14 times 4 is 56. And if you subtract or you add a negative, then that becomes positive 10. So the 4 has to be negative because when you add these two, that gives you positive 10. And when you multiply them, that gives you negative 56. All right, so now you look at this middle variable, which is x, and that's what you put here and here. And so now you want to write 4 terms out, the first, second, third, fourth. So the first term, second term, third term, fourth term. And these are interchangeable. These can be reversed. The order does not matter. You'll get it right either way. And now you have a 4-term polynomial, which can be factored by grouping. So if you do the grouping method, you're going to put parentheses and group those first 2 terms and take out the GCF, which is 7x. And now we have x plus 2. And then here you're going to take out a negative 4 is common to those 2 terms. And if you take out a negative 4, you're left with x plus 2. Once again, you can distribute to verify that that actually gives you negative 4x minus 8. And remember, these 2 factors should be equal, which they are. So that means we can factor that out. And when you factor that out, that means you're dividing it out. And that leaves us with 7x minus 4. And remember, the order of these factors does not matter. You can have this one in the front, this one in the back, or vice versa. They're interchangeable. As long as you have the 2 factors, that's the important part. Okay. So here we have a rational expression that we need to simplify. And for this, we can create 2 diamonds, one for the numerator, one for the denominator. So A times C for the top one would be 1 times 6, and B is 5. And so for this one, it's going to be 3 and 2. Whenever the leading coefficient is 1, you don't have to factor by grouping. You can just take these two numbers that you came up with and place them into the parentheses directly. So it's going to be x times x, and then you have a positive 3 and a positive 2. Same goes with the denominator because the leading coefficient is 1. So that's going to be A times C is 15, B is 8, 5 and 3 should work. And there will always be a unique set of numbers that work. And if there's not, that means it's not factorable. So we get x plus 5, x plus 3, and there are common factors that can be simplified or canceled out, and that leaves us with x plus 2 over x plus 5 as our final answer. All right, the next one, let's see, we have x plus 3 in the numerator. Here we have a difference of 2 squares. That's going to become 2x plus 3, 2x minus 3. And then the division becomes multiplication, and then we have to flip the second fraction. We multiply by the reciprocal. So let's do the bottom diamond, which is now going to be, the top is now going to be the bottom, and A times C is 12, and B is 7. That's going to be 4 and 3. So that's going to go to the denominator now because we flipped it. So x plus 4, x plus 3. And then for the other one, we do also need a diamond for that one. That's going to be negative 30 on the top. Remember, we do A times C. Careful not to miss that negative. And B is 7. And the two numbers that should work here are 10 and 3. And we need one of them to be negative. Since it's a positive 7, that means we want a negative 3. And this time the leading coefficient is not 1. So therefore we do have to place this x here and here and factor by grouping. So remember the 4 terms would be 1, 2, 3, 4. So that would be 2x squared plus 10x minus 3x minus 15. Now we can do the grouping method. Take out the 2x, GCF, and that leaves us with x plus 5. Over here, the GCF would be negative 3. That would be x plus 5 again. And then we can take out the x plus 5 because it's common. And that leaves us with 2x minus 3. So we have x plus 5, 2x minus 3. And now we want to look for common factors that can be canceled. And I see x plus 3's, 2x minus 3's, and that is it. So our final answer will be x plus 5 in the numerator, 2x plus 3 times x plus 4 in the denominator. Okay, for this problem, we're subtracting two rational expressions. So first step is to factor out the denominators. So if you factor out the denominator, you should get x plus 2x minus 1. And for this other fraction, you should get x, what is that, plus minus 4x minus 1. All right, and so now we see that our lowest common denominator is going to be, I'm going to create a little bit of room here by erasing this. The LCD is you need every single factor represented in your lowest common denominator. And you do not need to duplicate this factor. So as long as you have all the factors that are represented in the denominator, you should be good. So you need x plus 2 in your denominator. You need x minus 1. Then you jump over here and notice that you also need x minus 4. And you do not need this one because you already have it. So you don't have to write it again. All right, then you look over here and you ask yourself, which factor is missing from my LCD? Well, it looks like you're missing the x minus 4. So that's what we have to multiply top and bottom of. So times x minus 4, top and bottom. And you do the same thing to the other fraction. You ask yourself what's missing, and it looks like it's x plus 2. So x plus 2, top and bottom. And now we have a common denominator, which means we can simplify the numerators. So I'm going to go ahead and distribute, and careful not to forget the negative. The negative also gets distributed with the 2. So distribute here, and also distribute the negative. So that becomes x squared minus 4x minus 2x minus 4. Combine like terms, x squared minus 6x minus 4. And that should do it. In some cases, you'll be able to factor the numerator and simplify even more. But in this case, I'm looking at this trinomial, and I'm noticing that we're not going to be able to factor it. So that is our final answer. The final problem in this section wants us to rationalize the denominator because, as we mentioned, you're not allowed to have a radical in the denominator. So we need to rationalize that. And the way we do that when there's more than one term is you multiply by what's called the conjugate. And the conjugate is when you multiply by the same expression, except you change the sign in the middle to be the opposite. So instead of minus 5, you want to multiply by plus 5. And we're rationalizing the denominator, not the numerator. That's why we're taking the conjugate of the denominator. And whatever you do to the bottom, you must do the same exact thing to the top to keep it equivalent. And now we just have to expand the top and expand the bottom. So let's start with the top. So we do first, we're going to get radical t squared, outer plus 5 radical t, inner plus 5 radical t again, and last plus 25 over First is radical t squared. Outer is plus 5 radical t. Inner is minus 5 radical t. And last is minus 25. Notice these two terms are opposite, so they cancel. And then whenever you have the square root of a square, well, the square and the square root cancel. This just becomes t. Same with this. Cancel, cancel. This becomes a t. And so our final answer will look like t plus, notice these two are like terms that can be combined. 5 radical t plus 5 radical t is 10 radical t plus 25 all over t minus 25 is the final answer. And now there are no longer radicals in the